Chapter 4 begins with quadratic functions and graphing quadratic functions specifically that are in the standard form. A quadratic function is anything that has an x squared term in it, and the standard form of that simply looks like this: y equals ax squared plus bx plus c. If you graph that equation, the graph will be a parabola, and a parabola is this U shape that I have here. A parabola has a vertex, which is simply the place where it turns, going from down to up. So in this case, it's the origin. And the axis of symmetry, a parabola is symmetrical. So the axis of symmetry is where you can fold it in half, and the two halves would match. In this case, the axis of symmetry is the y-axis. What the graph that I have here is y equals x squared, and this is what we call the parent form of the graph of a parabola. And so what we're going to do is we're going to start with that parent form, and we'll manipulate the numbers and see what that does to the graph, and then from there we'll be able to come up with some formulas. So the first one that we're going to do is y equals 1/2 x squared. So we're going to graph it, and then we're going to compare it to that parent graph. So to graph this, we're simply going to choose points and put them in a table like you've done and like you love doing so much. Normally I would just pick like 1 and 2, but because this is going to be multiplied by a half, I'm going to pick some even numbers. So let's start with -4, -2, 0, 2, and 4, and simply plug those numbers in for x. So -4 squared is 16, and half of that is 8. -2 squared is 4, and half of that is 4. So 2, half of 4 is 2, yes. 0 squared is 0, and half of 0 is still 0. 2 squared is 4, and half of 4 is 2. 4 squared is 16, and half of 16 is 8. So now we have our coordinates. We simply plot them. -4, 8 is up here. -2, 2 is about here. 0, 0 is our vertex. 2, 2 is here. And 4, 8 is in our notes, but that's okay. And so then we simply connect the dots in a smooth curve. And you know the artist that I am, it's so beautiful. So now what we have is another parabola. It's the parabola that matches the graph y equals 1/2 x squared. And then we can compare. The things we're comparing is where's the vertex, where's the axis of symmetry, how wide and narrow is it, those types of things. And so you can see that the vertex is the same. The axis of symmetry is the same. But you can see that the graph is a bit wider. So the graph is wider. So the only thing we changed was we multiplied it by a half. And the only thing that changed in our graph is that it became a little bit wider. So we can see that probably if we're going to multiply by a fraction, our parabola is going to get wider. So let's now graph another one. And this time we're going to graph the equation. Which one will it be? It will be y equals -2x squared plus 4. And so we're simply going to use I'll use another color. Hopefully you can see it in this light. Let's choose just -2, -1, 0, 1, and 2. And the same as before, we're going to put the x's in and get out a y. So -2 squared is 4. 4 times -2. So -8 plus 4 is -4. -1 squared is 1 times -2 is -2. -2 plus 4 is 2. 0 times -2 is still 0, plus 4 is 4. 1 squared is 1 times -2 is -2, plus 4 is 2. 2 squared is 4 times -2 is -8. -8 plus the 4 is -4. So then when we plot these points, We're going to do -2, -4, which is down here. -1, 2 is here. 0, 4 here. 1/2 up is here. And 2/4 down is here. And then we simply use our lovely artistic abilities, which hopefully yours are better than mine, and make a nice smooth curve. And there's our parabola that might be a little wobbly, but it'll work. All right, so we're going to compare that. And always remember, if I ask you to compare, please do so. All right, so you're going to compare it to the parent graph. You can see, first of all, the obvious thing is that this one opens down, whereas your first graph opened up. So the difference is opens down. Your vertex is no longer at the origin. Your vertex is now 4 up. So the vertex is up 4. And the other difference would be, I don't know if you can tell because one is up and one is down, but this graph, the green graph, is a little bit narrower. It's more narrow than your black parent graph. So it is a narrower parabola. So by doing this, we can see a few things, and we can make some generalities of some properties of these parabolas. The first property is that if you have a positive A, if the A was positive, then our parabola opened up. Whereas when it was negative, our parabola opened down. So you can look at a formula or at an equation in standard form and quickly and easily see, is that parabola going to open up or down? Simply look at your A value. All right, the next thing you're going to see is that when we multiplied by a whole number, our parabola was more narrow, whereas when we multiplied by a fraction, it was wider. So you can either use the absolute value of A. The absolute value of A is greater than 1. Well, that simply means a whole number. If the number is a whole number, then it's going to be narrower. Whereas the absolute value of A is less than 1, or if it's a fraction, it's going to be wider. The C, if you'll notice, C is what we added here. When we added 4 to our squared term, it moved our vertex up. C is going to be the y-intercept. So C is not necessarily always going to be where your vertex is, but it will be where your parabola crosses the y-axis. So the point 0C will be on your parabola, or will be on your graph. So the last thing that we need to know is something that we haven't seen yet, because we haven't used that middle term yet, that B term. The x-coordinate and the axis of symmetry The x-coordinate and the axis of symmetry can be found with the formula -b/2a. So this is the x-coordinate of your vertex. So I just told you that the C is not necessarily always where your vertex is. It is a point on the graph. The x-coordinate is going to be found with this formula. So let's do one that has all three. and we'll use those properties this time. All right, so we'll start with y equals negative x squared plus 6x minus 8. So the first thing we need to remember is, well, what's our a and our b and our c? And so we can see that the coordinate, the coefficient of x squared is negative 1. So our a is negative 1. And then our b is 6. And our c is negative 8. So using what we know that the a is negative, so we know that it's going to open down. We know that our a, since it's a 1, it's not going to be narrower or wider. It's going to be the same width as our parent graph, so it's not going to narrow or widen. We also know that we know that b is 6, and so we can find our vertex by using this negative b over 2a formula that I just gave you. So negative 6 over 2 times the negative 1. So that's going to be 6 over negative 6 over negative 2, so that's going to be a positive 3. So what this gives you is the x coordinate of where your vertex is. So you're going to find the y coordinate by putting it back into this original formula. So you'll put in y equals negative 3 squared plus 6 times 3 minus 8, and simply simplify that. So 3 squared is 9, so negative 9 plus 18 minus 8. When you simplify that down, you get 1. So your x is 3, your y is 1, so your vertex is 3, 1. All right, so now what we have see if I can neaten this up a little bit so that our graph isn't quite so. I'll see if I can find a way to do graphs on this board better. All right, so then our vertex is going to be at 3, 1. 1, 2, 3 over 1 up. So there's our vertex, and we know that it's going to open down, and we need another point or two to match it up. We don't know, it's going to be about this wide, but let's give ourselves something to go on. We know that, do you remember we said that the negative 8 is the y-intercept. So, oh my, 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be a point on our parabola way down here. And because this is our axis of symmetry, so our axis of symmetry is x equals 3. That's the axis of symmetry. That's where it's going to fold in half. So if we have a point here, we go 1, 2, 3 this way, and then we go 1, 2, 1, 2, 3 this way. So we're going to have a point equidistant on that. Oh my goodness, and my points are not the same distance apart. Oh my. Okay. So then the parabola zip, zip, is going to look like this. So in other words, knowing those properties, you don't have to use your table to find your points. So you know that, by the A, you know whether it opens up or down, you know if it's going to be wide or narrow. Using that B term and this formula, negative B over 2A, that gives you the X coordinate of your vertex, and then you plug that X into your original formula to get the Y coordinate. So there's your vertex. And from there you find, if you find one other point, you've actually found two other points because it is symmetrical. Now the only other thing I want to cover today is minimum and maximum values. When you have a parabola, the vertex is the point of turning. And so if your values are going down and down and down and down, the vertex is going to be where it turns and goes up. So a parabola that opens up is going to have a minimum value where that point of turning is, or where that vertex is. So the minimum value is going to be the place where your vertex changes direction. Now if your parabola opens down, then the change occurs at the top of the curve. So this parabola would actually have a maximum value. So, lovely eraser again. We'll find a solution to this somehow, some way. So a minimum value is going to occur in a parabola that opens up. So in other words, if the A is positive, then that parabola will have a minimum value. The maximum values, if you see the arrows indicate that the parabola is going to continue forever. So there is no maximum value. It goes on to infinity. But it does have a minimum value, and that's the place of turning, or that's the vertex. So that's going to be the lowest point of your parabola. So the maximum value The maximum value will occur if you have a function that has a negative a. So if your a is negative, then that function will have a maximum value, and that maximum value is going to be the y value at the point of the vertex. So on both of these, you know that if the a is positive, you have a minimum value. If the a is negative, you have a maximum value. To find what that minimum value or maximum value is, you need to find your vertex. Once you find your vertex, the minimum or the maximum is simply going to be the y value of that vertex. And I think that's all we have for today. There's a lot.